Now we look at what's called the argument of a complex number. And the argument of a complex number is an angle, okay? And usually we're going to pick that angle to be some angle between 0 and 2 pi, so that we're basically within one positive revolution of the coordinate plane. Now, the argument is not unique, meaning different complex, one complex number can have many different arguments because you don't have to put this restriction on that your argument's between 0 and 2 pi. So your argument could be negative if you rotate in the negative direction. It could be past one revolution of the coordinate plane, etc. Okay, so that's kind of interesting about the argument. But it's the angle that corresponds to the terminal side for the complex number, and we usually label it with the Greek letter theta. Okay, so let's see what this means. It's the angle that corresponds to the terminal side. So determine the argument, determine theta for each of these complex numbers. So the best thing to do is to visualize the complex number so you can see the terminal side. And so if I graph the complex number 3 minus 3i in the complex plane, then I've got 3 on my real axis, so I'm going to move right 3, and I'll move down 3, so this distance here is 3, and then I go down negative 3, and my point lands over here. So my terminal side is right there. So what I want to know is the angle that puts me at this terminal side. So I measure from our standard position, which is to the right, there's 0, and I rotate in the positive direction to land here. So I need to know what angle this is. This is my theta. Well, the good news is for us is that if I were to draw a right triangle, the two sides, the two legs of this triangle are length 3, which means that this is a 45-degree reference angle, or pi over 4. So that means that I'm pi over 4 short of reaching around back to 2 pi. So it's 2 pi minus pi over 4, if you wanted to see how it's calculated, but it ends up just being 7 pi over 4. So the argument of this complex number, 3 minus 3i, is 7 pi over 4, because that's the angle that corresponds to the terminal side of that complex number. Okay? So let's look at this next one. Z equals negative 7i. Let's graph it. Real axis, imaginary axis. I go 0 on the real axis, but I go negative 7 on the imaginary axis. So I'm down here at negative 7. And my point, my complex number, is right here. So my terminal side is this side right here, the point that goes, or the line that goes to my point. And my angle theta rotates from our standard position in the positive direction. This is theta. And we should all know that this is 3 pi over 2. So the top is 1 pi over 2, 2 pi over 2, 3 pi over 2. And so that's all there is to it. No triangle this time. Okay, let's do another one. So this time I'm going to move left on my real axis, negative 2 square roots of 3. And I'm going to move up 2 on my imaginary axis and get my complex number, my point, over here. And my terminal side is right here. So my theta is going to be this angle. In order to know that, I better know my reference angle down here. So I look at my reference triangle, and this side's 2, this side's 2 square roots of 3. What I can do is use my inverse tangent function of my opposite side 2 over my adjacent side, 2 square roots of 3. And notice I'm not taking into account the negative when calculating my reference angle. I never do. But if you calculate that, you will see that this is a 30-degree reference angle, which is the same as pi over 6. So my theta value is almost over here to pi, but it's short of pi by pi over 6. So I need to take pi minus pi over 6, which gives me 5 pi over 6 as my theta. Okay? So my argument for this complex number is 5 pi over 6. Okay, finally the last example, my real axis, my imaginary axis. I need to go to negative 10 on my real axis, which is over here. And here's my complex number. My terminal side is right here. My angle theta is measured in the positive direction, and we all know that that theta is pi. So that's my argument for the complex number negative 10. And that is all there is to argument, the angle formed with the terminal side of the complex number.